Hello, it's me again, and today we're going to be going over the basics of trig. I believe I made another video before, but that one I didn't really like, so I decided to go over it again, and I've made it a little bit more easy to understand, and it looks a lot better. So let's start with our triangle. So we're going to do everything in terms of this angle over here, theta. Let me get my laser pointer. Yes, there we go. So now we have our angle theta. That's what this circle with a line in between means. And that's what we're naming this angle on the side. So one thing you might have noticed is that there's a square right here. This means this is a right triangle. If you know the Pythagorean theorem, it talks about legs and a hypotenuse. So these are the legs of the triangle, the parts right next to the right angle. And then this is the hypotenuse, the side directly opposite to it. And now we're going to use this angle to start to name these sides. This one is still going to be named the hypotenuse. This one is going to be named the opposite side. And we're naming it that because it's directly opposite from our angle theta. And this side is going to be named adjacent, for the same reason why we named this one opposite. It's because it's right next to our angle theta. So what our trig functions do is that they measure the ratio in between different sides. This is useful because you can define an angle just by its function. You can define an angle by putting it through a function and then seeing what its sides give on a triangle. We can make these any length we want, and the length will change based on theta over here, and we can scale it up or down if we want to. So here's the first function we're going to do is sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you might notice if you divide sine by cosine, the hypotenuses cancel out, and it just becomes opposite over adjacent. So that's another way you can define tangent. And you can use that same method to find definitions for sine and cosine. Now we have the reciprocals. Cosecant is hypotenuse over opposite. This is the reciprocal for sine. Secant is the reciprocal for cosine, which means hypotenuse over adjacent. And cotangent is the reciprocal for tangent, adjacent over opposite. And I just put the triangle over here so you can see. A warning, cosecant is 1 over sine, not 1 over cosine. I know a lot of people who get this wrong, so this is something very important to remember. Same thing applies for secant. It's 1 over cosine, not 1 over sine. However, cotangent does equal 1 over tangent. Cotangent is the reciprocal of tan. And here's the second warning. I consider this bad notation. I know a lot of people who do, but a lot of people like to write the inverse function of sine. We call it arcsine now. They write it sine to the power -1 of x. This is not cosecant x. I know some people think that because taking something to the -1 is the same thing as its reciprocal. Same thing with cosine and same thing with tangent. These all have their own inverse functions, arcsine, arccosine, arctan. Same thing with their reciprocals, arccosecant, arcsecant, and arccotangent. Let's take a look at the graphs so we can figure out some stuff about these functions. Here's our sine function. I took this off of Desmos. It might be a little bit of low quality. However, I did enlarge it so you can see the numbers. And here are the points of interest. First thing is, at 0, we have 0, 0. We have pi over 2. This should be a pi over 2. There's a pi over here. It's directly in between. Pi over 2 at 1. -1 at 3 pi over 2. And then it's 0 again at 2 pi. Notice how this actually repeats. Once we get to 2 pi, it actually starts again. This is an oscillating function. It stays the same. It just flips itself around, going up and then going down, then going up, then going down. Sine of x is considered an odd function, meaning it's symmetric around the origin. If you took this graph going the other way, you would actually see that it is symmetric around the origin. Flipping it 180 degrees doesn't actually change the function. F of x is greater than 0. We're considering the domain 0 to 2 pi. F of x is greater than 0 from 0 to pi. And f of x is less than 0 from pi to 2 pi, as shown here. Okay, here's a image of the cosine function. This one looks a lot more weird. One thing we should notice is that at this point, x equals 0, cosine of x equals 1. When you get to pi, it goes to -1. And at pi and 3 pi over 2, it equals 0. And at 2 pi, it goes back to 1 again. This is also an oscillating function. All trig functions are oscillating functions, so that's important to know. And oscillating functions have a period, which is how long it takes to get back to the original position. And for sine, cosine, the period is 2 pi. So once you get to 2 pi, it's as if you started at 0 and you just continued going again in a loop. Cosine of x is greater than 0 on the intervals 0 to pi over 2 and 3 pi over 2 to 2 pi. This area and this area. And it's less than 0 from pi over 2 to 3 pi over 2, right here. The last one we're going to be showing the graph of is the tangent function. This one is interesting because it has asymptotes, which I graphed over here because I didn't want to put the entire graph of tangent. So, point of interest, at x equals pi over 2, you notice I drew a line there. That means it's not defined at this point. The left side is approaching infinity, the right side is approaching negative infinity. Same thing at 3 pi over 2, and this one also oscillates. This one has a period of not 2 pi, but of pi. You notice that each of these sections is repeating itself. Or you could just say it's oscillating from pi over 2 to 3 pi over 2, because at that point the entire thing is continuous. F of x is greater than 0 from 0 to pi over 2, where it's undefined, and then pi to 3 pi over 2, where it then becomes undefined again. It goes from 0 to infinity on both of these points. At f of x, if you're looking for when it's less than 0, it's from pi over 2 to pi, and 3 pi over 2 to 2 pi. It's going from negative infinity to 0. F of x is not defined at x equals pi over 2 and x equals 3 pi over 2, as shown here and here. Yes, the unit circle. So this is a circle that assumes that your hypotenuse is always going to be 1. And it has written the degrees in both degrees and radians. Most of the time you're going to be using radians. Not often at all you're going to be using degrees. Degrees is more normal for people to use because it doesn't involve constants like 3.1415. So that's used a lot. But when you're doing higher level maths, you're usually just going to be using radians like pi over 6, pi over 4, pi over 3. And below them are their degrees equivalents. Now if you see the coordinates on the side, this just tells the length and the height of each of the two sides, if you can read it correctly. So the way you read it is, this first number is going to be the length of the adjacent side, and the second number is going to be the length of the opposite side, because this is the x-coordinate, this is the y-coordinate. X is distance along the x-axis, y is distance along the y-axis. At 0 degrees, it's 1, 0. So our adjacent side is going to be 1. Our opposite side is going to be 0. And this should give you a clue about why cosine of 0 is 1, because the adjacent side is 1. Hypotenuse is also going to be 1. This is still considered the hypotenuse. 1 over 1 is 1. And for tangent at 0 and 0, pi over 2, 0, comma 1. Remember that tangent of theta is opposite over adjacent. 1 is our opposite side, 0 is our adjacent side. 1 over 0 is not defined, so that's why it's undefined at both here and here when the adjacent side is equal to 0. This is something useful to remember. These are typical triangles that you would use. The 45-degree triangle is just a triangle where both the adjacent side and the hypotenuse are the same length. And the pi over 3 and pi over 6 triangles, those are equilateral triangles. They're just taken at 2 different points. I'll leave it up to you to find out where at what 2 angles of the equilateral triangle these are taken care of. Here's a mnemonic I like to use. I got this from my math teacher, and I find it very useful to use. All students take calculus. All meaning all the trig functions, sine, cosine, tangent, and the reciprocals. Students meaning sine, and its reciprocal cosecant. Take, which means tan, and its reciprocal cotangent. Calculus, cosecant, and its reciprocal secant. Well, it is true. If you're going to go into college, you're probably going to take calculus. So all students take calculus. Very useful to remember, and very useful when trying to figure out where your trig function is going to be positive. This just tells you where it's going to be positive. All, sine, tan, tan, cosine. Here's just some more useful stuff you probably want to know. If you're given the angles of a triangle, it doesn't have to be a right triangle in this case, and you're given at least one of the sides, you can calculate what the length of the other sides are using the law of sines, meaning the length of one side over sine of the angle opposite from it. Notice that A is directly opposite from capital A, is equal to you doing that same thing except with a different line and the angle opposite to it. So if I were to plug this into a calculator, the length of A divided by sine of the angle of A should equal the length of B divided by the sine of the angle B, which should then equal C divided by sine of angle C. So this just says, because you know that all the angles of a triangle should add to 180. All you need to know to find all the sides and angles of a triangle is just 2 angles in one of the sides, and then you can figure out the third angle, and then you can use law of sines to find the lengths of all the sides. Law of cosines is assuming you only have one angle, but you do have all 3 sides. So in this case, it can help you calculate the angles. C squared is equal to A squared plus B squared plus 2AB times cosine of C. So 2AB times cosine of C. And remember, cosine of pi over 2 is 0. So for a right triangle, this is just saying A squared plus B squared equals C squared. Some sum formulas you might want to know. This is the sum of sines. It equals cosine A times cosine B plus cosine B times sine A. Sorry, I said cosine over here. This is a sine function. I like to think of this as cosine and sine are sharing the load. Cosine is like, I'm going to take A, you take B, and then afterwards I'll take B, you take A, and we'll add it all together. For the sum of cosine, in this case, cosine is a little bit greedy. He's like, I'm going to take both a and b in this section. You're going to take you're going to take b and a for the next part, and you're going to minus your amount from my amount. And I'm not sure what you're going to say for tangent. It's a large thing. It's just the tangent of each of the two angles, a and b, tan of a plus tan of b, divided by 1 plus the product of the tans of the two angles. Okay, I hope you enjoyed watching today's video. Let me know in the comments if you need some more help with math, and I'll make some more videos. Well, until next time, see ya.